Hey, hello everyone. I'm NikhilPandey. So I'm going to explain the data science assignment 3, first part, question 6, all the question 6. So we'll directly move on to first question, that was ELBO in variational autoencoders and diffusion models. So let's talk about the ELBO first. The evidence lower bound, that is stands for ELBO. In VAEs, ELBO balances two terms, reconstruction loss and KL divergence. It encourages the decoder to rebuild the original input while pushing the latent distribution closer to a Gaussian distribution. In diffusion models, ELBO takes the form of variational inferences across noise steps where the KL divergence penalizes deviation from a learned noise schedule. In both cases, minimizing ELBO helps the model generate realistic samples while maintaining a meaningful latent structure. That was our first question. And if we'll move to the second question, that is beta value in VAE objective. What is the objective of beta value in VAE? In beta VAE, we modify the standard ELBO by introducing a beta parameter to scale the KL divergence. A small beta means good reconstructions but poor latent disentanglement. A larger beta encourages the model to learn disentanglement and interpretable features at the cost of slightly blurrier reconstructions. This trade-off is key when we want more structured latent spaces, especially in tasks like unsupervised representation learning. That was our second question that we solved. The third question, we are moving to the third question, that is diffusion process theory. What is diffusion process theory? Diffusion models work by gradually adding noise to data in a forward pass and then learning to reverse this noise step by step to generate new data. The forward process is fixed and Gaussian, while the reverse process is learned. This probabilistic approach avoids mode collapse and leads to high quality generation, making diffusion models state of the art in many areas like image synthesis and audio generation. Those were the examples of diffusion model. Now we'll move on to the fourth question, that is Gaussian VAE loss plus reparametrization. A Gaussian VAE loss combines binary cross entropy reconstruction with a KL divergence between the learned latent distribution and a standard Gaussian. To backpropagate through the sampling step, we apply the reparametrization trick, that is Z equals mu plus sigma times epsilon. This keeps the whole model differentiable, enabling end-to-end training and allowing the latent space to become smooth and meaningful. That was our fourth question. Now we'll move on to the fifth question, that what were the research paper that we went through in all four full spring semester. In this course, we basically explored several foundational papers. The VAE and the autoencoding variational bias paper taught us about structured latent learning. The diffusion model survey helped us understand noise based generation. GAN papers like DC GAN and Saliman's tricks showed us how adversarial training works. Each paper provided insights into different generative paradigm. Actually, a VAE for likelihood modeling, GAN for adversarial training, and diffusion for denoising based generation. That was our fifth question, talking about all the research, most of the research papers that we went through in our spring semester, 2025 spring. And we'll move on to the sixth question, that is why learn GANs, VAs, diffusion, and transformers. Why these are important in the current market situation of AI. So learning GANs, VAs, diffusion models, and transformers is crucial in 2025 because these are the backbones of modern AI. Actually, VAs and GANs are powerful for generating structured data. VAs and GANs are powerful for generating structured data. Diffusion models are now state of the art in image and audio synthesis. Like most of the AI models today uses diffusion models to generate state of the art images and audios. Transformers revolutionized NLP and are now being applied across domains. Like ChatGPT uses transformers to generate most of the data and answers what we prompt. Understanding these models equips us to innovate across fields from generative AI and multimodal learning to real-world applications in finance, healthcare, and beyond. So these were the six questions that we solved in our assignment 3. I hope you all have understood. Thank you very much for listening to me, and have a good day. Bye bye.